Alright, here's a video on our concept inventory number 2. I'm going to try and go through this as fast as I can to make sure that you have the answers to study for the quiz. A molecule of water contains hydrogen and oxygen in a 1:8 ratio by mass. This is a statement of blank. I want you to look up each one of these so you know and you have your own definition for them. What I say might help and might not. Law of multiple proportions. That means CO, one of each of them, can exist as well as like a CO2. Different proportions, but same molecules, same elements in different molecules, and that's okay. Done. Law of conservation of energy. Well, if I have energy over here, and it goes into some kind of reaction, Rxn, what comes out of it is the same amount of energy. So if I have 96 at the start, at the end of a reaction, I will also have 96. I don't gain or lose anything. That's why it's called conservation. Same with the mass. If I put mass through a reaction, what comes out is the same mass that went into it. So if I had 240 going into my reaction, I'll have 240 coming out. Law of constant composition. That's interesting. That tells me that if I have, say, H2O, the mass composition of that would be 2 AMU hydrogen plus 16 AMU for oxygen, yielding 18. So my ratio is 2 to 16 by mass, or 1 to 8. Now that tells me that if I ever have hydrogen and oxygen with that ratio, 1 to 8, it's going to be the only one molecule, and that's water. So constant composition means something is only something. It can't be something else. So water can be only water. It can't be alcohol. It can't be methane. It can't be anything else but water. So water is water. So the answer here, D. Cool. I know, that was extensive. Here are substances that can illustrate the law of multiple proportions. I think we just went over that. That is easily that one. The charge of an electron is determined by, I do want you to look these up. They can be confusing. Give a quick basic knowledge, one sentence about what each of them have done. But this one created a charge, or discovered the charge. The gold foil performed here. Gold foil experiment performed in Rutherford's lab was used to lead to the discovery of the nucleus. In Rutherford nuclear atom model, the heavy subatomic particles are in the nucleus. Okay, so that is what we're talking about when we have some rings and then a whole big nucleus in the middle. Right? Remember that nucleus in the middle, that's positive, and then electrons are negative outside. Cool. Well, the following smallest and lightest subatomic particle is, you guessed it, the electron. It's about 0. So, all atoms of a given element have the same length. Well, they all have the same number of protons. Right? That indicates a given element. Cool. So if you have element X, here's our atomic mass, here's our atomic number. The atomic number is the number of protons. Which is the smallest number of neutrons? Well, let's draw this out. If you have carbon, I have a mass of 14, that's what this number, these numbers are for. Atomic number 6, and that's 8. Fluorine has a mass of 19, atomic number 9, is 10 neutrons. Nitrogen, mass of 14, 7 atomic number, that gives me 7 neutrons. We have neon, 20 and 10, that gives me 10 neutrons. And then oxygen, well, that's 16 and 8, and that gives me 8 neutrons. So here, nitrogen, that is our smallest number of neutrons. Cool, so we just kind of went over this. 132 minus 35, or minus 54, that gives me 78 for xenon. Okay, that's the number of neutrons. So there's only one over here that can have 54, 54, and 78. Remember, if it's a neutral molecule, that means the protons equal the number of electrons. Therefore, the charge is equal, 0. Atom most common isotope of gold is 197 AU. Okay, look up 79 is my atomic number. It gives me 118 neutrons. So looking up at our answers, that'll be A. Isotope is 36 electrons in this atom. Well, 36 electrons is equal to our protons in the bottom number right here. Oh, not bottom. This bottom number here, that gives me the proton or the atomic. Okay, moving on. Which isotope is 36? Oh, just that one. Isotopes are atoms that have the same length but differing length. Isotopes are atoms that have the same atomic numbers but different mass numbers. In the symbol below, blank equals X. Well, 14, 6 carbon. The symbol below X is what? X is referring specifically to the mass number. In the periodic table, the elements are arranged in order of increasing atomic properties, atomic number, reverse alphabetical, increasing neutron content. They are in order of increasing atomic number. So atomic number 4 has 4 protons, atomic number 5 protons, 24, etc. Which element blank is in the same physical and chemical properties? Same group of the same periodic table. Those are the same physical and chemical properties. So remember, this way, these are groups, and these are friends. These are periods, and they're frenemies. Or frenemies. Cool. Which pair of elements would you expect to exhibit the greatest similarity in their physical and chemical properties? So this is asking me very the same thing. Which ones are in the same group? Those. An element in the upper right-hand corner of the periodic table is definitely metalloid or non-metal. Either definitely metal. These are definitely non-metal. So we have that staircase separates the non-metals from the metals, and along the staircase, well, those are considered metalloids, kind of half and half. So if it's way over here, that's definitely non-metal. Which of the following molecular forms is the empirical form? Empirical, you have to, when you hear the word empirical, you have to think lowest common denominator. Every time you hear that word, that's what you have to think, lowest common denominator. Which one can be reduced more? If it still can be reduced, it's a molecular formula. If it can't be reduced at all, it's the empirical formula. That would be this one, because there's a 1 here and a 1 there. Ones cannot be reduced anymore. Which compounds do not have the same empirical formula? That's pretty easy. That one cannot be reduced anymore. This one can be reduced, all the rest of them can. Cool. Ooh. Molecular formula always indicates the geometry, the simplest whole number ratio of different atoms, how many of each atom are in the molecule. Keyword molecule, which is a combo of atoms. Awesome. Blank of the following contains the greatest number of electrons. Well, greatest number of electrons. Electrons are negative, so which one's more negative? That's what our question is asking. Because electrons are negative, and this one has the largest negative charge. Which pair of elements is most apt to form a molecular compound with each other? Keyword molecular compound. Molecular is going to refer to a bond between nonmetals plus nonmetals. They make molecules. Ionic compounds, they refer to a metal bonding to a non-metal. And we'll talk more about this later on in the next couple of weeks. But I want to kind of throw this at you. Molecular compound, non-metal, and non-metal. So which ones of these are non-metals? So for 4. And then if we scroll down a little bit, which of them, the ionic compounds, are going to be metal and non-metal? That is pretty easy. Barium and bromine, both a metal and a non-metal combination. These are both nonmetals. These are both metals, both nonmetals, both metals. If an atom has 3 electrons to make an ion, what is the charge of that ion? Negative 3. Which one of the following compounds is chromium 3 oxide? Now here's important, this Roman numeral, these Roman numerals is equal to the charge. That's how we name a charge, chromium 3. So, now this is going to get complicated and we're going to talk about it more. But, if I have a chromium and oxygen and my charge is 3, and metals are positive, nonmetals are negative, these are going to switch spots. Just the numbers, not the signs. Leaving me with Cr2O3. Now, we're going to get into this in more detail. But what I do want you to take away from this is that these indicate the charge of chromium. Awesome. Which one of the compounds is copper 1 chloride? Well, chloride, we'll talk about, is always a negative 1. Copper is a positive 1, so mix those together, we can have a balanced equation right there. These two are the hardest, and we're going to get more into them next week. But right now, it's good to kind of start it out. So don't feel bad if you don't know this at this point. Okay, which group with a fictitious element blank, 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 blank be found? So, now that's where it gets confusing. This is the elemental notation of electrons. Now there's 7 electrons here. Now, 7 in the outer ring. It doesn't say how many are in the inner rings, just 7 in the outer rings. Right, 7 in the outer ring. So if we count the center in the outer ring, that's always going to be in 17, the very end. Or, I think it's 8 or 7A, something like that. Alright, potassium sulfide. Sulfide, that's an S2 minus. Potassium, that's a K plus 1. For those two to match up, it's going to be K2S. And we'll talk about that. But here's a 2, it goes there. Here's a 1, that goes there. What is the name of an alcohol derived from hexane? Well, hexane, in your naming, we'll drop off the N, we'll add an OL for alcohol, as in alcohol. Hex and L. We'll definitely talk more about that in class. A lot of this stuff we haven't gone over, so I'm intrigued to see how you guys did. And if you have any questions, we'll talk about them. Excellent.